for an example. So it says we are given circle O with a diameter of segment AD. We have tangents at line BF and line CF. We have secants at line PE. Let's see here, where's PE? PE is here, PD, and PC. Okay, so we probably need to draw that PC in. So PC would go like that. It's not drawn in the picture. Okay, we know to be given that angle DOC, so my central angle is 78 degrees. Angle DRE, that's a chord angle, is 82. And arc BC is 90. We want to find all of these parts. Okay, so one step at a time here. So to find, if I start with the first one, angle BFC. So BFC, notice the vertex is outside the circle. So to find angle BFC, it's half the difference of the two arcs. So one of the arc is 90. That means the other part, again, if it makes a full circle, would be 360 minus 90, which is 270. So to find angle BFC, we're going to take half of 270 minus 90. Because again, if the minor arc is 270, the major arc would have to be, or I'm sorry, if the minor arc is 90, the major arc would be 360 minus 90, which again is 270. 270 minus 90 is 180, and half of 180 is 90. So this angle is 90 degrees. Continuing on, number 2, angle CBF. So CBF has a vertex on the circle. So CBF, notice again the vertex is on the circle. So to find this angle, it's half the measure of the intercepted arc. The arc is 90, so half of 90 is 45 degrees. Okay, continuing further here. For number 3, arc DC. Okay, so again, if I'm looking at the picture, let me grab a colored pencil here. We knew angle DOC, which is a central angle, is 78. That means its intercepted arc here is also going to be 78 degrees. Okay, and again, continuing further here. To find arc AB. Okay, so arc AB is this little piece here. And we knew that we had a semicircle from the beginning of the problem. So our semicircle is going to go from D all the way to A, because it talks about AD as a diameter. So a semicircle is 180 degrees. If I know two of the pieces, 78 and 90, so if I add 90 plus 78, that gives me 168. So that tells me that arc AB, if I take 180 minus 168, this is going to be 12. So again, that's going to be 12 degrees. So we're 4 out of 10 here. Moving on to number 5, angle DPC. So if I'm looking at the picture, DPC is this one here. And let me grab a colored pencil here to make it easier. So DPC, the vertex is outside the circle, so it's half the difference of the intercepted arcs. So the two arcs we're talking about within this blue angle here are the 78 and the 12. So I'm going to take half of 78 minus 12. Well, 78 minus 12 is 66, and half of 66 is 33. So this angle DPC is going to be 33 degrees. We're halfway there. Okay, continuing on, we have angle BEC. So let me grab another color here. So for angle BEC, it's this one here in red. Okay, where's the vertex? It's on the circle, so it's half the measure of the intercepted arc. The arc would be this 90 here, so we're going to take half of 90, which is, again, 45 degrees. So this angle DEC is 45. Continuing on. Next, we're looking for angle DRC. Okay, so again, DRC is this one here. Now, let's make this easier on ourselves. They told us in the problem that angle DRE was 82. these two angles together make a straight angle. So let's use that concept. So a straight angle has a sum of 180. So if I take 180 minus 82, that gives me what, 98 degrees. So again, this angle is 98. I use the concept that, again, those two angles have to form a straight angle, and 180 minus 82 is 98. Okay, continuing on here. Next, we have arc DE. Okay, that is this one here. So there's different ways we can approach it. Okay, one of the ways is going backwards. If we know that this angle is 82, to find that arc, we would take half again. Let me erase that. So let's right up here where we have space. So my angle, which is 82, is 1/2 the sum of the intercepted arcs. So I don't know what arc DE is, so I'm just going to write DE. And then the arc that goes with its vertical is going to go from A all the way to C. So that would be 12 plus 90, which is going to be 112. So if I'm thinking I'm going to solve for arc DE here, the first thing I would do would be multiply both sides by 2. So 82 times 2 is 164. And then we have arc DE plus 112. So to continue solving, I would subtract 112 from both sides. So 164 minus 112 is 52. So again, the measure of arc DE is going to be 52 degrees. Okay, we got two pieces here yet. So angle EMA. So let me grab a different color again. Let's grab the screen. So again, EMA has a vertex on the circle, so it's half the intercepted arc. The arc has to go from E the long way all the way around to A. So it's half of the sum of those arcs. So I have to add 52 plus 78 plus 90 to get, and then finally, I almost forgot, plus that little piece of 12. So when I add that together, that's 232, and half of 232 is 116 degrees. Okay, and then finally, we are looking for angle OCB. So angle, let's see if I can find it here looking at the picture, OCB. Okay, so think about this. OC is a radius, this is a tangent. Remember our theorems, a radius and a tangent are perpendicular. So that means that angle OCB is 90. Okay, so that is it on explaining the examples and the theorems for angles related to a circle. And as always, if you have questions, please let me know.